Ever get that feeling? Like something you remember just isn't quite right anymore.
Like a detail shifted.
Yeah, like a movie title is suddenly different. Or a brand from your childhood has like a new spelling.
That mismatch between memory and reality, huh?
Yeah, and it turns out it's surprisingly common.
You're not alone in feeling that, not at all.
And like our source for this deep dive points out,
It's almost like a glitch in reality, they say.
yeah, and they use some interesting examples, like the Berenstain Bears.
So many people remember it with an E at the end.
Berenstain, right?
Yeah, and Febreze. Some remember a different vowel sound.
Oh, interesting.
Even the Statue of Liberty?
Yeah, some people swear it was on a completely different part of the island.
Exactly.
So these glitches in reality, as our source calls them, they've really taken off online. People call them the Mandela Effects, which is kind of a cool name.
It is. It is.
So this brings us to the big question we're tackling in this deep dive. And it might sound a little out there, but bear with us. Could the work being done at CERN, with that huge, Large Hadron Collider, could that have anything to do with these weird shared memory glitches?
Right. It's a fascinating connection.
Yeah, I get to see.
It's speculative, definitely, but fascinating nonetheless.
And we're going to be exploring it using excerpts from this document called How CERN Broke the Internet and Reality as We Know It, .pdef.
Now, it's important to remember this source has a specific viewpoint. It suggests a link between CERN's experiments and these changes to reality, as they put it.
Right, so our goal is to really unpack these theories, dive into the quantum mechanics and parallel universes and all that heady stuff the source talks about, and hopefully give you a better grasp of these ideas.
A clearer understanding, yeah.
So right off the bat, the source throws out some wild explanations for these Mandela effects. One of them is the multiverse.
This idea that our universe isn't the only one.
Right, that there are other universes out there.
Exactly. And this is where our source really reflects the current multiverse theory. It suggests that for every choice, every outcome, there's a separate universe. Every path not taken, taken in another reality.
Whoa, that's a lot to take in.
A whole tapestry of realities branching off at every single moment.
So this is where it gets really interesting. Our source asks, could our universe somehow have bumped into another one?
Almost like merged with another reality.
A reality that's almost identical, but with tiny differences that we're suddenly noticing.
Right, like two versions of the same story overlapping.
And suddenly we're confused about the details.
Exactly. It's a really far out theory, but it's one way to try and explain why so many people share memories that don't quite match up.
Okay, so if we're even going to entertain this possibility of universes bumping into each other, our source points the finger, metaphorically, of course, at CERN.
And more specifically, at the Large Hadron Collider, the LHC.
So tell us about this thing, this LHC. What is it exactly?
The LHC, it's an incredible feat of engineering. Like the source emphasizes, it's the largest machine humans have ever built. We're talking a 27-kilometer-long circular tunnel.
A 27-kilometer loop underground.
Yeah, imagine that. Almost a marathon-length tunnel underground, crossing international borders. And its purpose, to accelerate particles, like protons, to nearly the speed of light.
Nearly the speed of light.
99.9999991%, to be precise.
Wow, that's mind-bogglingly fast.
Yeah, almost impossible to grasp. And they smash these particles together, releasing tremendous energy. And from those collisions, all sorts of other particles are created, and scientists study them.
So they're basically smashing things together at unimaginable speeds to see what happens.
In essence, yes. And by studying these collisions, they can learn about the fundamental building blocks of the universe and the forces at play.
And has the LHC been successful in doing that?
Oh, incredibly.
Oh, good.
It's led to new particle discoveries that have filled gaps in our understanding of particle physics. We're talking about the Standard Model, which is a best explanation so far for the fundamental particles and forces, except for gravity.
So really groundbreaking stuff. But as our force also points out, generating that kind of power, it raises questions about possible unintended consequences, right?
It does. The source talks about the immense energy needed to run this huge machine and the possibility of some weird side effects, let's say.
Weird side effects from smashing things together at the speed of light. What could possibly go wrong?
Well, it's natural to wonder what might happen when you concentrate so much energy into such tiny spaces. Early on, there was skepticism about the LHC. People were worried it could create microscopic black holes or even rip holes in space-time.
Micro black holes. That sounds like something out of a sci-fi movie.
It does, but scientists took those concerns seriously. Most agreed that any black holes created would be incredibly tiny and disappear almost instantly, so not really a threat. But those fears were definitely out there.